Hey everybody, Miss Glad here. Just gonna work through some problems with you. So if you could grab that brand new yellow note packet, looks like this for Unit 2, and we are starting today on page 3. So go ahead, grab that and get all set. So we're gonna start with some fractions and looking at some division problems that are a little bit more tricky. So let's go ahead and get started here. I'm starting on letter G. And notice on my notes it says to get rid of a fraction, we're going to be multiplying by the reciprocal. So today, as we're working through our multi-step problems or two-step equations, we've got a few things to remember. So we're going to start with letter G. First thing I'm going to do is I want to find my equal sign. So I can see that and go ahead and draw a nice straight line. I'm going to do my best here with my mouse. But our goal is to get that variable x all by itself. Right now I've got this fraction multiplying by 1/3 and the plus 1 attached. So if you remember, we want to reverse PEMDAS. So we're going to start with our adding and subtracting. Then we'll move to multiplying and dividing. So let's go ahead and look at this adding 1. I know that I can go ahead and clear that out or remove that by using the inverse, which is subtracting 1 on the left. And then to keep it balanced, we're going to subtract 1 on the right. So I'm going to go ahead and draw my teeter-totter. So right now everything is balanced. And let's go ahead and show that this plus 1 and minus 1 cancel. So we are left with 1/3 times x, which is equal to 4. Okay. So now this one's a bit different than we've solved in the past because we've got this fractional part connected to x, but it's no big deal. We know that to clear fraction, we're actually going to multiply by the reciprocal. You might recall that to divide fractions, you actually never divide, you flip and you multiply. So that's exactly what we're going to do here is I'm going to take this fraction 1/3 and I'm going to find the reciprocal. It means I'm going to flip it around and I'm going to flip it to times 3/1. So we'll multiply by the reciprocal on the left. Come on over here. Multiply by the reciprocal on the right. And now if I multiply 3/1 times 1/3, 1 times 3 on the top, 3 times 1 on the bottom, 3/3 cancels to be 1x, which is exactly what we wanted, our x equals. Now I'm multiplying 4 times 3/1. I really don't need that fractional part 3/1. It's the same as 3. So I'm just going to go ahead and multiply 4 times 3, which is 12. Now let's do a quick check to make sure it all works. 1/3 of 12, so 1/3 times 12 plus 1, does that equal 5? That's what we're here to check out. Well, I know 1/3 times 12 is 4. And I can think about using, again, my multiplication. 12 on the top divided by 3, so 12 thirds is 4. Now plus my 1. So here, all of this equals 4 plus 1. Yes, it does equals 5. It checks out. Okay, awesome. You just did your first fraction two-step equation. Let's take a look at letter H. Letter H is set up in a similar manner. I have 3/4 times x minus 1 equals 2. So we're going to find our equal sign here, and we're going to put our line in. That is the center to our equation. So right now everything is balanced, but our goal is to get that x by itself. So once again, we're going to reverse PEMDAS. We're going to start with our addition and subtraction to try to remove. So use the inverse. So here, the subtracting one, I'm going to add 1 on the left, and then I'm going to come over here and add 1 on the right. So I'm going to draw on my teeter-totter, and everything is balanced perfectly right now. So what we can do is we can go inside and we can do a little bit of work. My 1s are going to cancel. +1, -1. They drop out. I don't need that 0 anymore. But I am left with 3/4 times x, which is now equal to 3. So I've got a one-step equation left, and notice I'm taking 3/4 times x. So once again, to get rid of a fraction, we can multiply by the reciprocal. So what I'm going to do is I'm going to flip 3/4, and I'm going to multiply by 4/3 on the left. and multiply by 4/3 on the right. So remember, dividing fractions, we never actually divide, we flip and we multiply. So 4/3 times 3/4. Well, we know that reciprocals equal 1. So here, if I multiply the top, 4 times 3 is 12. On the bottom, 4 times 3 is 12. 12 over 12 is equal to 1. So all of these cancel to be a nice whole 1x, which is the same as x, equals 3 over 1 times 4/3. So if I go ahead and multiply on the top here, I get a 12 on the top, 3 on the bottom. So 12 divided by 3 is 4. So that simplifies down to x equals 4. Now I can check. 3/4 times 4 over 1. Oops, that's a times. So times 4 over 1 minus 1 equals 2. Let's just verify that we did everything correctly here. Your handwriting looks much better than mine, I'm sure, on here. So on the top, I get a 12 over 4. So 12 divided by 4 is 3. 3 minus 1, yes, does equal 2. Boom, we got it. Our last fraction problem, I noticed that I've got 3/5 times x plus 22 equals 28. So I'm going to use the same process that I've used on the last two. I'm going to follow my equal sign, and I'm going to say, yes, there is the center to my equation. My variable x happens to be on the left-hand side, and we need to isolate that variable. So to do that, I see that I'm adding 22, and I'm multiplying by 3/5. So PEMDAS reversing says we got to start with the adding and subtracting first. So I'm going to begin by subtracting 22 on the left and subtracting 22 on the right. I'm going to draw my teeter-totter so everything is balanced. My 22's cancel, and I've got 3/5 times x, which equals 6. So now, as we know, we want to get that x by itself. So to get rid of or clear out our fraction, we're going to divide by 3/5. But we never actually divide fractions, we flip and multiply. So here it comes. I'm going to flip my fraction. It's going to be 5/3 on the left. So multiply by 5/3 on the left, multiply by 5/3 on the right. So my reciprocals turn out to be 15 over 15, which is equal to 1. So I've got a nice big 1 over here, 1x, or just plain old x. Got a little multiplying to take care of here, no big deal. I know that this is like 6 over 1 times 5 over 3. So this turns out to be 6 times 5 on the top is 30. And my denominator, 1 times 3 is 3. Let's go ahead and simplify that. 30 divided by 3, you got it, turns out to be a nice 10. So x equals 10. So here, if I double check that, 3/5 times 10 plus 22, let's see if I can squeeze all this in, equals 28. Oh, I might have to write on top of me or move me. I don't usually have my camera on, but it's on right now. So there's my 22 under there. Oops, 28. There we go. Oh, I did it. I moved myself. There we go, 28. Okay. So 3/5 times 10. Let's go ahead and multiply. So this is like 3/5 times 10 over 1. On the top, I get 30. 3 times 10 is 30. On the bottom, I get 5 times 1, which is 5. So 30 over 5 is 6. So all of that turns into 6. I'm going to just write it right over it. 6 plus 22 is 28. Got it. Nice work. All right, thanks for following along. We are almost to the end. We've got 3 more to complete our page 3 here. And notice that these look a little bit different, but I'm going to talk about them. We're going to finish off J, K, and L. Then you're going to get some work time today for your first homework assignment for solving equations. So let's take a look at letter J. So notice that I'm first of all going to find my equal sign. So here's my equal sign. I'm going to go ahead and put my line in. So I want to find the center to my equation. There it is. Now, that tells me that I want to get to x. I want x equals in the end. But notice that x has a number with it. It's this fractional part. And if you remember in GEMDAS, this fraction is actually considered a grouping symbol. So this part we're actually going to do last. That x plus 2 is kind of a combo package. You could actually surround it in parentheses if you wish, because it's considered a grouping symbol. So on this type of problem where you've got your numerator of x plus some number divided by 4, our first step is actually not going to be adding or subtracting. It's actually going to be multiplying or dividing. So this dividing by 4, what I'm going to do is I'm going to multiply by 4 on the left, and then I'm going to come over here and multiply by 4 on the right. Excuse me. So my divide by 4 times 4 cancels. And then I end up with x plus 2, which is equal to 2 times 4, which is 8. So that one's a bit different. Starting out with dividing, we had to clear out the division. So we multiply by 4 on the left, multiply by 4 on the right. So now look at how much easier our equation is. Now, notice that I kept the x and the 2 together. I said consider them like a grouping symbol because they are together on top of our numerator, that fraction bar. Now, if you want to keep the parentheses there, you can, but you really don't need them. There's nothing else to do. So now I would continue with my process of solving to get my x alone. Here, I would want to subtract 2 on the left, which means I would subtract 2 on the right. I'm going to draw my teeter-totter so everything is balanced. My 2's cancel, and I'm left with x equals 6. So definitely much shorter steps than those fraction parts that we just were on. Now let's just verify that this actually works. So on the top, I would do, let me come back here. I don't even see my little eraser, but it would be my x is a 6. So it's 6 plus 2 on the top divided by 4. Does that equal 2? So if I were to solve this, again, remember this is a grouping symbol. So right here, I'd have to put the 6 plus 2 together, which is an 8. So does 8 divided by 4, does that equal 2? Yes, it does. So remember, we reversed GEMDAS and we had to divide first, which if you look here, we divided last. So it absolutely worked. We know that x equals 6. These are kind of tricky. Let's try our k. So right here, k, I'm going to find my equal sign. I'm going to put my line in. Okay, so everything is balanced, and our goal is to find our variable for x. So what is x? What is that going to be? So to begin with, again, notice that this is set up where x minus 3 is in a grouping symbol above this dividing by negative 2. So we must kind of think of this as a grouping symbol together. So here on this one, we're actually going to start by removing the divided by negative 2. So I'm going to multiply by negative 2 on the left, and then I'm going to come over here and multiply by negative 2 on the right. So divide by negative 2, multiply by negative 2 are going to cancel. They are inverse operations. And I'm left with x minus 3, which equals a negative plus a negative is a positive 2. Now we're almost there. To isolate our variable, the subtracting 3 is our last step, so I'm going to do the inverse, which is add 3 on the left, add 3 on the right. So when I draw my teeter-totter, my 3's cancel, and I've got x is equal to 5. So when I check my answer, I'm going to put a 5 in for x right up here. I'm going to go 5 minus 3. All of that divided by negative 2, does that equal negative 1? So remember, this is like a fractional part here. This time now I'm going to start with it because 5 minus 3 is 2. So let me put my 2 in there. 5 minus 3 is 2. So does 2 divided by negative 2 equal a negative 1? It absolutely does. It works. Last practice problem for today. I've got x plus 7 in the numerator divided by 2. That is equal to 6. So my first step is to find my equal sign. I'm going to go ahead and put that in so everything is balancing right now. Our job is to use inverse operations to solve for x. So our goal is to get the x equals all by itself. So once again, in the numerator, this is a grouping symbol, this fractional part on the numerator, x plus 7. So I need to, first of all, remove this divided by 2. So I'm going to undo this by multiplying by 2 on the left, multiplying by 2 on the right. So my times 2 divide by 2 cancels, and I've got x plus 7, which equals 12. Now, my x plus 7 is almost there. We just have one little step left. That x plus 7, the inverse of adding 7, is subtracting 7 on the left. So whatever I do to the left, I must do to the right to maintain our balance. So right here, my 7s cancel out. A positive 7 and a subtracting 7 or negative 7 cancel. So I've got my goal. Here's my x is equal to 12 minus 7. So 12 minus 7 I know is a 5. So it looks as though x equals 5, but we better double check to make sure. So I'm going to put my x, which is a 5 in. So it's 5 plus 7 is my numerator, divided by 2. We want to know, does that equal 6? So together on the top, this is my grouping symbol, which I would put 5 plus 7 is 12. So 12, now we can divide 12 divided by 2. Yes, it does equal 6. So have you guys seen this meme? I love it. It's one of my favorites. Teacher's face when you don't show your work. Do you guys know who that is? Rihanna. You'll have to Google it if you don't know her song. So today, your assignment is to complete the practice problems for level 1, level 2, and level 3. Notice that there is a challenge section. Go ahead and try that. It says using the digits 1 through 9 at most one time each, fill the boxes to find the least possible values for x. So here you are using digits 1 through 9. You can only use them at one time each. Use the boxes to find the smallest possible values for x. Okay. I'm going to come back to, so your level 1s, okay, again, show your work. So to get you started here, you're going to find your equal sign, put your line in. Okay, so looking at this first letter A, always the trick is we want that x to be all by itself. So remember, you're reversing PEMDAS. You're going to start with any addition or subtraction. Right here, I see that 6 is going to go first. So I'm going to subtract 6 on the right, which means I'm going to subtract 6 on the left. That's tricky sometimes. I'm going to draw my teeter-totter. My 6's cancel. So what's left here, the subtracting subtracting 2x turns into a negative 2x. So negative 2x is equal to 4. So go ahead and finish that up. You want to get that x all by itself. So remember, it's a multiplying by negative 2. So the inverse of multiplying by negative 2 will be dividing by negative 2 on the right. Coming over here, dividing by negative 2 on the left. So negative 2 divided by negative 2 is 1. So our very first solution here, x is equal to 4 divided by negative 2, which is negative 2. We can put a negative 2 and check it. 6 minus 2 times negative 2. Well, 2 times negative 2 is a negative 4. I almost put my answer in there. So this is a negative 4, so it's 6 minus a negative 4. Does that equal 10? Keep change. Why, yes, it does. Keep change. 10 equals 10. We are good. Move on to your next. Find your equal sign. 3 times A plus 12 equals 24. I know my first step. I'm going to reverse PEMDAS, subtract 12 on the left, subtract 12 on the right. Draw your teeter-totter. Keep on going. 12s cancel. 3 times A is equal to 12. You're almost there. So 3 times A means that you're going to use the inverse of multiplying by 3. Divide by 3 on the left. Divide by 3 on the right. 3 divided by 3 is 1A. A equals, you finish that one off. Have a great day. I will see you tomorrow.